Welcome to the class on probability. We'll discuss a very important topic of engineering mathematics. This topic is more important because it has significance in terms of aptitude questions also. If you see the weightage of probability in GATE examinations is somewhere around 4 to 6 marks. Now a single chapter containing such a big weightage is really very important. I have considered the aptitude part also here in 4 to 6 marks as well as the engineering maths part also. Right? So let us start with the fundamental things. First, let us discuss what is the basic definition of probability. Now, if I say the word probability, the word probability basically means in a very layman's language possibilities, right? Possibilities. But if you say the mathematical definition, you say the mathematical definition of probability. Mathematical definition. The mathematical definition says that probability of any event is given by the favorable number of cases, the cases which are in favor of that event divided by the total number of cases. You would have studied this thing in your engineering days or your earlier classes also. Nothing special about this, right? Let us take an example. We'll understand it better if you could get it. Like for example, there is an event of tossing a coin, right? And I want the probability of getting a head. Now, if you say, if I toss a coin, when you toss a coin, what are the possible cases which I can get? I can get either a head or I can get a tail. This set, this set is called as sample space. So we'll be regarding this set which contains all the possible outcomes will be sample space. I'll talk about sample space. Let us come to the example. I said if I toss a coin, what is the probability of getting a head? So when I toss a coin, how many favorable cases do I have? I have only one favorable case. And how many total cases I had? I had total 2 cases. So the probability becomes 1 by 2, or you can say 0.5, or in percentage terms if you talk about, it is 50%. In a GATE exam or any of the PSU exams, you will find that question has options in terms of decimals, or it can also have options in terms of percentages, right? So this is the basic definition. We will use this very frequently. Before moving ahead, let us also discuss something on properties or of probabilities. Special points you can say or probabilities. Number one, if you talk about properties, the probability of any event, the probability of any event is always between 100% and 0%. Right? You will agree to this point because the probability cannot be more than 100%. For any event, for example, if I say India will win the match with a probability of minus 20%, seems absurd. Minus 20% is not possible. Or if I say India will win the match with a probability of 235%, so this is also an absurd statement, which is not actually correct, right? Or in absolute terms, if you say probability of any event, let's say A, is always between 0 and 1. So we will remember that if you're getting an answer which is 1.2 or 3.5 or in a negative way, that is not acceptable. The answer should be between the range of 0 to 1. So that is very important property. Second thing, let's say if I say that probability of happening an event is, let's say, PA, right? And if I say probability of not happening an event is denoted by PA bar. Now, if I say that probability of happening an event is, let's say, 40%. So can you tell me what are the chances that this probability of not happening of that event? Yes, obviously it is 60%. How did you go to 60%? I said 100% minus 40%, which comes out to be 60%. So what I can generalize is that probability of not happening an event is nothing but 1 minus probability of happening of event. That is what we did, right? Or if we generalize this thing, we can also say probability of happening an event or probability of not happening an event is coming out to be always 1. This will always be 1. This is a very important result which we'll be using in our examples in the further stages also, right? So let's now move ahead with types. Probability here would be, I will define questions in 5 types. I will define types of questions. You will find uh, types of questions I'm talking about. You will find all the types of questions which comes on probability in these 5 types which I'm going to discuss next. Right? Any book, any question, any set where you are taking an aptitude test or an technical test which contains probability as a topic will contains questions from these 5 types. I can guarantee you this front that these are the types which will be asked in your papers. Right? So the first type of questions which are asked are based on points. We have seen all coins here, right? For example, if I toss one coin, case of one coin, so what are the elements in the sample space we have talked earlier also, right? Sample space is nothing but is a set of all the possible outcomes, is a set of all the possible outcomes of an event could be anything. Event could be tossing a coin, beating someone. Event could be anything, right? So sample space for one coin, I am denoting it by SS, that is sample space, is nothing but you can get a head or you can get a tail. So we have discussed this case earlier. The probability of getting a head in a toss of single coin is nothing but 1 by 2. We have discussed this particular thing already. Let's say there is a case of two coins being tossed simultaneously, right? In a gate paper, you cannot expect questions on single coin or single throw. Ahead, further we will discuss cases of dice also, where you cannot expect a question coming on a throw of single dice, because in the gate level examinations you have to consider that you have to say at least two throws are important. So when you talk about 2 coins, right? So in order with the sample space of 2 coins, yes, it will be something like you can get a head on first, tail on the second, or head on first, head on the second, or you can get tail on the first, head on the second, or you can get tail and tail on both of the dice. These are the possible cases. And you have to consider that these dice are unbiased dice. Now, what is unbiased? Right? Biased dice is which is not correct. These dice are unbiased. Right? A biased dice is something which you have seen in a movie called Sholay, which contains both the sides same. So in a question, if it's giving bias, this is corrupted one. This is corrupted one, right? So it has some disparity, right? This is absolutely a general dice which we are using. So this corrupted one will be mentioned in the question, especially if it is not mentioned. I am always going to consider that it is an unbiased coin, right? Okay, so in a sample space of 2 coins being tossed, we have 4 elements. So total number of cases becomes 4, right? Now let us take an example. Let's say if I toss 2 coins, let's take an example. If we toss 2 coins, now here I have not mentioned whether it is biased or unbiased. So what we are going to take? We are going to take unbiased coins, right? So if we toss 2 coins simultaneously, then find the probability of getting at least one head. Let's say this is the question, right? So let us try to find out the sample space first. Sample space is mentioned above also. Let us redraw it. The sample space will have 4 cases: head, 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 tail, tail, head, and tail, tail. Right? What is the definition of probability says? Probability definition, we want what probability? We want probability of at least one head. What do I mean by at least one? At least one means I can have either one head or I can have two heads. Can I have three heads? How can I have three heads? I can have only two heads because I have tossed two coins. Right? Can I have zero heads? No, I cannot have zero heads also. Right? So this is the probability which I am looking forward for. Right? So let us go to the mathematical definition and talk that what are the favorable cases I can see. What are the favorable cases? Probability says it is nothing but favorable cases upon total number of cases. So at least one head probability, if I say, what are the favorable cases? Let us go back to the sample space. What are the favorable cases? Is it a favorable case? Yes, we have at least one head. Is it a favorable case? Yes, we have two heads, right? In fact, you needed only one, at least one. So this is also favorable? Yes. Is it a favorable one? No, this is not favorable. This is not favorable. So how many favorable do we got? 1, 2 and 3 favorable cases. So we have 3 favorable cases. And how many total cases we got? The total cases we got were 4. So the probability becomes 0.75, or if the option says in percentage, it will become 75%. Clear? Right? So similarly, you can get different questions. We'll discuss more questions when we discuss the questionnaire part. Right? So that was case of 2 coins. What if it was a case of 3 coins? Can you draw the sample space of 3 coins? Right? 3 coins are being tossed simultaneously. Right? So let me draw the sample space for you guys. We can have head, head, head on all the 3. Or we can have head, head, tail. Yes, we can have head, tail, head. We can have tail, head, head. We can have tail, tail, tail. We can have tail, tail, head. We can have tail, head, tail. Or we can have head, tail, tail. Right? Again, these are unbiased coins. Remember, these are unbiased coins. Right? So these are the possible outcomes. Any other outcome we can find out? No. There will be 8 outcomes. Now, there's a very interesting thing which we need to note here is that the number of outcomes is nothing but the powers of 2. So you try to understand. This is a very important logic because some difficult level questions will be solved by this fundamental. What I am trying to say here is, when we had one coin, I had 2 to the power 1 outcomes. When I had two coins, it's not one, I had 2 coins. The number of outcomes were 2 square, that was 4. When I had 3 coins tossed simultaneously, how many outcomes did we get? 2 cube, that is 8. So can you tell me, if I throw 6 coins simultaneously, how many outcomes we may expect? 2 to the power 6. Right? That would be how much? 64 outcomes we can expect. Now, is it important to draw this 64 outcomes? We'll talk it later. Right? It is not feasible in a GATE examination to draw all the 64. But yes, this is important to note that in a toss of 6 coins, there will be 2 to the power 6. That means 64 outcomes. I'll tell you how difficult questions can be framed out of it. Right? So let us come back to our discussion on 3 coins. So if 3 coins are tossed simultaneously, we have also discussed that your cases would be something like this. Right? These are your sample space cases. Now if I ask you probability of getting exactly 2 heads, probability of exactly 2 heads. Exactly 2 heads means you want exactly 2 heads. It cannot be less than 2 or greater than 2. Exactly 2 heads means, is it the case of exactly 2 heads? No. Is it the case of exactly 2 heads? Yes. Is it the case of exactly 2 heads? Yes. Is it the case of exactly 2 heads? Yes. What about this? No. What about this? No. What about this? No. What about this? No. So how many favorable we got? 1, 2 and 3. So 3 favorable out of 8 cases. So the probability becomes 3 by 8. Got it? Is very clear to us?